Good morning. My name is Mr. Royce. This is Algebra 2. Let's take a look at the questions on the homework. First of all, there was a question on number 10. So when we take a look at number 10, it is a multi-step process. We had to find the equation of the curve that passes through these 2 points. So first, I used the point 4, 8 to solve for a, to get a is 8 over b to the 4th. I did the process again with the point 6, 32. And since I have now 2 different expressions for a, and since a is equal to a, I can set them equal to each other, which enables me to solve for b. Then once you get b equals 2, you can plug it in either here or there to find the value of a. So just the big picture in this problem is that this is like a population that starts out at 500,000 people, and it doubles every year. Because a is equal to 1/2 and b is equal to 2. Now, are there any follow-up questions or specific points on this where perhaps the solutions were not clear? So we're okay on that? Now, we're going to start out today with taking a look at the concepts in 32 and 34. So take out a calculator. This is a calculator intensive day. And on your calculator, I'd like you to press the stats button. So here we go. Yeah. Oh.
Can I trade my dead calculator for a live calculator? Can I trade?
So, yeah, I've only got a few here, but yeah, you are responsible for bringing a living calculator to class. If you don't want to walk in front of the camera, you can walk around the other way, but so make sure you can get batteries on that. Alrighty, so it looks like we're back. We have our calculators. So I'm going to press the stat button and let's select the edit option. I have some points typed into list 1 and list 2. So I'm going to type these points into list 3 and 4. And just to give you an idea of what's going on, let's actually type in the numbers that are on the homework that's due tomorrow. That way we'll get a little bit of a head start on the homework, since the calculator work for problems 32 and 34 is the same calculator work that we need for the first problem on the homework. Now I'm handing out to you the homework worksheet that's due tomorrow, and it's a paper submission. So we are, by doing this problem here, we're going to be getting a head start on the homework. This is 2 sheets of paper, 4 sides, and we're going to do the first side of the homework right here in class. Let's take a look at what it says. Going to the 8.02 solutions. It gives you some, it looks like a lot of complicated directions, but when all is said and done, we're going to summarize all of these calculator directions into just 4 steps. Stat edit, stat calculate, zoom 9, and bars 5 EQ, and the y equals menu. So let's just go to stat edit and enter the numbers that you see in the lower left-hand corner. We're bringing a cup of coffee into the room. And did you guys not get the sheet? Okay. Very well. All right. So we're bringing a cup of coffee into the room. And it's 135 degrees above room temperature. So let's say room temperature is like 60 degrees Fahrenheit. 60 plus 135, that would bring the coffee up to 195 degrees, just a little under boiling. So that's the real world connection here. For list 1, please type in these multiples of 5 from 0 to 60. And for list 2, type in the numbers that you see. And when you finish typing those numbers in, it should look like this. So go ahead and type those numbers in by hitting Stat Edit. We're going to see how you're doing on the Stat Edit. So I'm going to do list 1 and list 2. Alrighty. Well, so Thomas, I think the calculator you have may already have list 1 and list 2 typed in. Secure. Right. Check. It's does it already have these numbers typed in? I thought MS being the other Thomas, holding off on last names since we're going to be on YouTube. And I'm making a video for you. Yes. Yeah, let me grab that for you, Tommy.
Sorry, it's okay.
No, it's okay. I hope I know that. There you go. Thank you for coming in. So, I think. Here's check. More. So, ooh, this one's old school. Yeah, okay. This one should work for you. Just 83. Oh, no offense. All right. So please raise your hand if you need more time. To type in the numbers in list 1 and list 2. All right. Okay. So let's try to decipher these calculator directions. What does it say? It says, hello, then go to second stat plot. Now, this is a nice thing about these directions is that you don't have to do them on the quiz or anything. These are one and done directions. This is just like the initial setup. So don't worry about having to do these every time. But yeah, that's it, stat plot, just like it says. And in case you're wondering where stat plot is, it's right above the Y equals button. So hit second stat plot. And it looks like we have like 5 scatter plots we could do. It says choose option 1 and press enter. Okay, option 1 is plot 1. Please join me in pressing enter. And in this one and done procedure, we just want to make sure that we're selecting on. If it's not already on, turn plot 1 on, which can be turned off from the Y equals menu. So if you ever want to turn it off, you don't have to go back and find this. There's a much easier way to turn it off when you want to get rid of it later. But we don't want to do a histogram or a box and whisker plot. We just want if we did want a histogram, we would hit enter there. But we don't. We want the scatter plot. So put the cursor on type right there. Some of you might have X list and Y list set up other than L1 and L2. So if you ever come into your calculator and it has like list 3 and list 4 for X list and Y list, you can change that. Is anyone in that situation where you have something other than L1 and L2? Okay, so if that's the case, here's what you do. Put the cursor to the right of X list, and notice that L1 is in blue above the number 1. So just press second 1, and then put the cursor to the right of Y list, hitting second L2. And there you're good to go. The mark I like, the biggest one is a square. Maybe you want to go with the crosses, the plus signs. The big points, the big golf balls or the little golf balls. Some people are into little golf balls. So I'm going to go with the boxes. And then you can select your color. My favorite color is green. I don't even know what your favorite color is. You'd think I'd know by now. I don't. Pick your color, and then let's do a zoom 9. Zoom 9 instantly sets up the viewing window. It doesn't say that on the directions, but it's a super shortcut. 9 is stat. So once you hit the stat button, do a zoom 9, and bam, there it is. Woo! What's that line doing there? Okay, that's a little bit of a, probably shouldn't have shown you that. But so here's what you, Hello.
Wait, what
Oh,
do you- I'm-
wow. So here's
I got upside down.
How do you get to the plot?
what, if you hit Zoom 9, if you hit Zoom 9, then you might get an exponential decay pattern that looks like this. Now, oh, by the way, at this point, we're gonna go surfaces away. Some of you have your surfaces out. Go ahead and just put those away. This is a non-surface
Wait, how?
activity. So surfaces just off your desks. So let's close one. Now, sounds like there's some questions here on how to get this set up. First of all, Gerald.
What was the type style?
Well, let's take a look. I'm gonna go to second stat plot because I can't even remember anymore. So the type, oh yeah, we're using scatter plot. The first one should be selected. Are there any other questions on how to get to the point where, yes, Anna?
So how do you get from there to the graph?
Hit Zoom 9. So Zoom 9, bam, there it is.
But,
Also known as blam. Yes, yes, Anna, question?
okay, it says like error.
Yeah, would you do me a favor, look at your y equals menu. We just want to see what's on y equals right now.
Oh,
Yeah.
wait,
So clear that, now do a Zoom 9. And it says, oh yeah, size of lists. Oh yeah, so you know what this says, the size of lists of the matrices. It could be that you just have a little typo in there, nothing to fret about, but I'm just gonna hit quit and go stat edit. And when I look at list 1 and list 2, I'm checking to see if you have the same number of numbers in each list. Oh, sure enough. So there was just a little bit of a typo. So go ahead and make sure that list 1 and list 2 are accurate. Then you don't even have to go back to that stat plot thing. Just do Zoom 9 and you'll be good to go. What Zoom 9 does, by the way, is this. It sets your viewing window up so you have breathing room. It looks like they want 6 units of breathing room below 0, and they automatically set up 6 units of breathing room above the maximum number of minutes that the coffee had been cooling. You know how in list 1 the biggest number you put in was 60? It basically gives you an extra 10% on X-min and X-max. And same thing for Y-min, Y-max. It gives you a little extra breathing room. I think the biggest Y value in list 2 was 135. It gave you a little extra. Yeah, question.
So why is it negative 5 and 55?
Oh, it doesn't matter. I mean, the point is that when you press graph, you can see all the points. And so that's what Zoom 9 does for you automatically. Now, the directions don't say use Zoom 9. The directions say set the window to fit the XY data, which is time consuming. So that's why I would like you to box the word window on your notes and instead write, or just do a Zoom 9, because then it does it for you automatically. The Zoom stat sets your window for you. All right, raise your hand if you need either time or help or both to get this to appear, this scatter plot to appear. Bethany, go ahead.
How do you do Zoom 9?
You know what? The Zoom button is right here, so it's top center. Press Zoom, the number 9, and blam. Further questions? All right. Well, let's see what else they have for us. Now we're going to calculate the equation of the line of best fit. And that's a stat calculate thing. By the way, now that we've done the stat plot, if you're going to be doing this on, let's say, Monday's quiz, all you have to do is go stat edit to enter the 2 lists, and then go to stat calculate. So stat edit, stat calculate is basically step 2, and calculate, just arrow over to the second submenu, and we need item 0. What am I expecting you to do? Scroll all the way down to item 0? No, press up arrow and that wraps around to the bottom. That's a faster way to get it. Or just hit 0 on the keyboard. It'll take you right there. Just stat calc 0 is what we say in the industry. So that should bring this up to your home screen. By default, Exponential Regression will take list 1 and list 2. If you want it to take lists 5 and 6, you would have to type those in separately. You'd have to go list 5. Don't do what I'm doing. List 5, comma, list 6. If you wanted some other lists in your Exponential Regression, but no. You want list 1 and 2. And so you don't even have to type in list 1 and 2. By default, they're in there. Then you can hit enter, it gives you A and B. Got to start somewhere and multiply by something every so often. Every minute, they're saying we started at 133 degrees above room temperature. And this model says that every minute, 94% of the degrees Fahrenheit show back up again, which means 6% of the temperature has left town. Let's pause here. Lauren, go ahead.
How did you get
How do you what? I'm
How
sorry.
did you get like the y equals?
Oh, what I did here. Well, this would be like an instant replay. Go to stat, arrow to calculate, and hit 0. Then simply press enter, and then it pops right up. Further questions? And now to get this, just simply
Mine just
press
did this, it didn't do that.
Right. Oh yeah, I've seen this one before. Now some of you, it's like it's asking you for all sorts of extra steps. Liberate yourself from chaos by pressing mode. Now this will make your life a lot easier. In mode, turn your stat wizard off. You currently, if you're dealing with that particular issue, and it is an issue, your stat wizard is on. So go ahead and turn your stat wizard off, and then it's like you've been released. You're free now,
Wait, what
because
did you
now when you hit stat, calculate 0, enter, you're done. You are done. You've got to start somewhere and multiply by something every so often. We're starting at 133 and multiplying by 0.94. So when it comes to filling in stuff on your homework, here's where you report your value of A. Just copy it down. Your calculator reported to you an A value of 133.46, a B value of 0.942, which means that the equation is y equals A times B to the x. So write it down. Write down the numbers reported to you by your TI-84 or TI-83. Okay? Let's just pause right here. Yeah, any questions on this? It's like a population problem. The line of best fit is a line that tells the story of a city where there's 133 million people at the beginning. And then every year, 94% of them show up again, which means 6% of them leave town. It's a 6% exponential decay rate, is what we would say about that. If it were people. It's not people, it's degrees Fahrenheit above room temperature. So, anyway, questions? We aren't done with this homework problem yet, but we made some good progress. Okay, so you got the equation written down. Now, they want you to find the height of golf ball 100, or in other words, what will be the number of degrees above room temperature 100 minutes after the coffee has entered the room? Coffee's in the room. It's like, you might be wondering, why are we doing this? But this can be used to solve murder cases, because when you got like a dead body in the room, it starts cooling down to room temperature. So if you take the temperature and you can actually work backwards to find the time of death based on the temperature of the body. And so these models can lock in time of death that stand up in a court of law in terms of evidence. So that can then start sorting through the alibis, the suspects, see if they have an alibi at the time of death. So when you put a body in a room, if it experiences death, then it will start cooling through exponential decay towards room temperature. Usually in schools, they try to stay away from talking like sex, politics, religion, and death. So they'll say, well, let's not do what they really do in the real world. Let's just talk about cups of coffee. It's like, ooh, coffee's cooling down. It's like, why are they making us do this? Well, there's a reason. There's a reason we're asking you to do this, because we want you to liberate people from suffering, the suffering that comes from having some murderer running loose in the community. We want to be able to incarcerate them, and that's part of what we're doing. Does anyone have any follow-up questions as to what on earth is going on? So yes, Bethany, go ahead.
What if it's already at room temperature? How can I tell?
Well, this would be used when it's not already at room temperature.
But if it was already at room temperature,
then it'd be a little harder to solve. It'd be harder to get
the murderer
evidence.
just be running themselves.
Further questions? All right, So let's take a look at how to find the height of golf ball 100. Now, there's a couple of ways to do this. First of all, we'd like to store the equation in the y equals menu. So let's talk through there are some steps here in terms of storing the regression equation. And the fastest way to store, after you've done stat calculate 0, to store the regression equation, really the fastest way to do it is go to the y equals menu, hit vars 5 eq1. So let's do that together now. Please go to the y equals menu. I'll give you a chance right now. But in the y equals menu, we're gonna clear that out. Please put your cursor to the right of the equal sign. Raise your hand if you need more time to get your calculator screen to look like this. So we're together. Okay, so here we go. The regression equation, instead of you having to type in this regression equation, it'll type in all the numbers for you. All you gotta do is hit the vars button, which stands for variables, I assume. I mean, I don't know what else it would stand for. So hit vars. And since we got all of our lists in the stat portion of the calculator, let's go to item 5. So vars 5, you can scroll down, either scroll down or just hit 5 from the keyboard. And we want the equation, the EQ, the equation. So right arrow over to the EQ submenu. Now, item 1, the regression equation, there it is. That a times b to the x is right here. So now when you press enter, your y equals menu, y1 will be populated with a times b to the x. Try it, press enter. Watch what happens. There it is, a times b to the x. Got to start somewhere and multiply by something every minute. So it's in. So now, hello, when you press graph, yeah.
Is that the same thing we just had though?
But now it has the graph, now it has the line of best fit going through it. And we can use that line, we can do a trace, you can do a trace 100 if we set up x max a little bit bigger than that. Now, before we trace 100, which cannot be done until, by the way, just heads up, they're asking us for the height of golf ball 100. So let's let x max be bigger than 100. Like, how about 110? Please go to Window, change your x max to 110, and then hit a trace 100, because that will tell you the height of golf ball 100. Trace 100, and actually there's something that graph trace. Notice it's on the plot right now, and now it's on the curve. So you have to switch back and forth between the plot and the curve. I want to trace not the plot. There is no golf ball 100 on the plot. But if you press down arrow and this comes up top, now I can trace 100. I think. Wait, hold on. Oh, that's Y1. Plot, down arrow. It's over here. Trace. Oh, what? I see what happened. When I pressed trace, it went back to plot. So when you press trace, then press down arrow to get onto the curve, and then the number 100. So now you can see that according to this model, the height of golf ball 100 is 0.35. It'll say error if you did not go to the viewing window and change X max to 110. So if you got an error there, then you just forgot, or for some reason did not go to window and change X max to 110. That's one way to find the height of golf ball 100. It's only 0.35 degrees Fahrenheit above room temperature after 100 minutes. Makes sense. It's cooling down. Any questions on this? Bethany, I know you had your hand up earlier. Do you still have a question?
Yeah, I can't find my equation to show up.
Okay.
I don't know.
Do you mind if I attempt to assist you with that? Oh, there it is. Oh, you know that. Oh. All right, so just talking out loud here. So I just want to make sure that you're See, your stat plot is true. And now, do a zoom in. Oh, I see. That was the only issue. So, check this out, Bethany, here was your situation. I went to stat plot, and your plot 1 was off. So that's the only thing you forgot to do. Once it's on, you won't ever have to do this again. It'll stay on. Now, go to your y equals menu, and to get your equation in there, tell me one thing, Bethany, have you done the stat calculate 0 step yet? Do you remember doing that? Okay, let's do that now. Yeah, you were probably stuck on that other thing. So go stat, arrow to the calculate submenu, and select item 0. Just press 0 from the keyboard. Does your calculator look like this?
Yeah.
Now press enter. Now it's calculated the equation. That's why you weren't getting a regression equation in there. It just wasn't there. Okay, now go to your y equals menu. Notice how plot 1 is turned on. If you ever wanted, if this ever happens again, you can just go up there. You can put the cursor up here, off, on, off, on, off. You know, so you don't have to go back to stat plot anymore. Oh, I turned mine off. Okay, so now mine's on. So is your cursor right here at y1?
Yeah.
Okay, so here's what we go. Here's what we go. All right, so here's what we do. Hit vars.
Yeah.
You with me on vars?
Yeah.
Okay. And
And
item
equation.
5, so it's vars 5 EQ enter. Vars 5 EQ. Now it's there.
And then I press.
Now it's there.
Yeah.
Yeah, zoom 9 or just, okay, now, but zoom 9 actually ruins what we did with window.
Yeah, just-
So after you did that, then, since they're asking for the height of golf ball 100, X max has to be at least 100. I'm going 110. And because even I ran into trouble when I tried to trace golf ball 100, let's all review the trace procedure. Here we go. We go trace, and notice that it's tracing the plot. By the way, you can't do that. Look, it's just the way I press right arrow, it goes to each point. I don't want to trace the plot, so I press down arrow because I want to trace the blue line. So now when I press 100, enter, it traces the blue line where x equals 100.
I did not get that.
Yeah. So now I notice that your curve is a little bit different, and which is, you know, interesting. So, but I am, to troubleshoot this, I'm going to go stat calc 0 enter to recalculate the regression equation, and then I'm going to go to the y equals menu and do vars 5 EQ enter, and now when I press graph it works. So I guess I just kind of like redid it and it worked. This kind of makes me happy. Any other questions?
And then how do you get to the far right with the?
Then, okay, so then to get to the far right, press trace, and notice that it's tracing the plot right now, which you don't want. You don't want to trace the plot, you want to trace lines. So press down arrow, okay, and now type in the number 100, followed by enter. And there it is.
Is that the temperature of coffee?
No, that's the number of degrees Fahrenheit above room temperature. Now, if this room happens to be located in Antarctica and the furnace broke and room temperature happens to be 0 degrees Fahrenheit, then yes, 0.354 degrees above 0 degrees Fahrenheit is 0.354 degrees. But if room temperature is 68 degrees Fahrenheit, then that means the temperature of the coffee is 68.3541034 degrees Fahrenheit. Okay? Further questions? Oh, did I turn the camera on? Yes, I did. So let's start over. No, where the camera was on the whole time. Any other questions on that? So, yep. So let's see what we've done. So what we do on our homework, that's due tomorrow, we say the temperature of the coffee at 100 minutes, yeah, that's a mistake. It's room temperature plus, yeah, oh, that's what it says. Oh, good. It says 0.383 degrees Fahrenheit above room temperature. So I don't know what room temperature is. They didn't tell us. Would have been nice if they told us, but they didn't. So we just say whatever it is plus 0.383 degrees. Okay, any follow-up questions on that one? Now for the drama. You knew the drama was coming, but the truth is, you don't have to do any of this to get a super good equation. I mean, the purpose of having you do this, you know, all the Algebra 2 students here at Wheaton Academy are doing this activity. But why are we doing it? It's because it is kind of nice to get to know how to use this exponential regression feature on your calculator.
We never have to use it again.
But, well, you know, I didn't say that because there'll be I expect, I haven't looked at the unit 8 test yet, but I mean, I'm pretty sure that since we're spending so much time on this, there'll be one on there. I just haven't looked yet. But you are responsible for being able to do this again. But if you do it again, in fact, let's just be aware. These are the only things you need to know. Go to Stat Edit, type in your two lists. Go to Stat Calculate and select item 0, Stat Calculate 0. Do an exponential regression. Then just do a Zoom 9, which sets up your viewing window, followed by go to the y equals menu, hit bars 5 EQ, and that will bring up the regression equation. So summarized, even though it looks intimidating, it's really just Stat Edit, Stat Calculate, Zoom 9, and then put the equation in there. You got it right there. So I do recommend that you jot down the summary. But here's something kind of powerful. And this is something that, you can get the equation without a calculator using just the first point and the last point. And it'll be actually even just a little bit. But it's basically the same thing. And to prove it to you, 0, 1, 35, and 64. Check this out. Hopefully you'll be able to squeeze this in. I think in the space down here, you can start writing what I'm about to show you. 0, 1, 35, 60, 4. Okay, check this out. Take the first point, 0, 1, 35, and 60, 4. Based on these, the first ordered pair and the last ordered pair, look at what you can do. In fact, you know what? It's going to be just like in an Algebra 1 course when they ask you to find the equation of a line that passes through 2 points. Suppose that you're in a universe where, this is called Newton's law of cooling, by the way, that tells you that you have exponential decay. Isaac Newton came up with it. He's a guy who discovered calculus back in the year 1666. What if the universe were different? What if coffee didn't cool down on an exponential decay? What if it were linear decay? What if we start out at 135 degrees and then it just cools 4 degrees every 5 minutes? What if that were the case? It just comes down 4 degrees every 5 minutes, rise over run. So down 4 over 5, down 4 over 5. If that were the case, then to find the equation of the line, you would say, well, we got to start somewhere, and we have to subtract 4 degrees every 5 minutes. I mean, the slope of the line is -4/5. So, Daniel, does this make sense to you? You got to start somewhere and add something every so often?
Yeah.
What if it just came down linearly like that? We start at 135, and you just go down 4 degrees every 5 minutes, down 4 over 5, down 4 over 5, down 4 over 5. So then instead of an exponential decay curve, we would get just a linear decay curve. Linear decay. Notice how the rise is -4 and the run is 5. And the only building blocks I used to build this model were the initial output, the output change, and the input change. Output equals initial output plus output change times input over input change. I only needed 3 numbers. Did you know that you can get the equation of exponential decay using only 3 numbers? Here it is. Instead of a caret, which is kind of sharp, kind of pointy, which means change means subtraction. Instead of 131 minus 135, do a smooth curve in arc. That means division, the output ratio. Instead of output change, let's just take 4. Instead of minus 135, let's take 4 divided by 135. Instead of subtracting, divide. And over here, what this means, I only need 3 numbers to build my exponential decay function. I've got to start somewhere and multiply by something every so often. So, here's the story of this cup of coffee. The temperature of the cup of coffee starts at 135, and we multiply the temperature by this tiny fraction, 4 over 135, every 60 minutes. And we just came off of a unit on fractional exponents, so we actually know what this means now. We actually know that this can be rewritten as 135 times 4 over 135 to the 1/60th power. And all that is raised to the x power. That's A and that's B. A is 135, B is 4 over 135 to the 1/60th power. This is powerful, not even using a calculator, it's a powerful way to write equations from data. Look at how it compares to what we just did on the calculator. So, join me by going to the calculator. Please hit second quit. And let's type in our value for B. I mean, just using my 2 points, I got 4 1/35 to the 1/60th power. Check this out, parentheses. 4 divided by 135, caret, parentheses, 1 divided by 60. That should be the same value of B that came up when we did the homework here. Let's see, let's check this out. The value of B that the calculator gave us using exponential regression was 0.942. What did I get? 0.943. With hardly any work. And you're all still with us? So yeah, so hoods off here. That's how we roll here. I should have said where we are. We are here at law. Might as well tell the truth. Okay, so there it is. Here it is.
Mine says error.
Same.
Just kind of type it in like this. Just type in parentheses. 4 divided by 135, parentheses, caret, parentheses, 1 divided by 60. Now,
Well, the carrot's just like a blank box. Like, how do you use it?
oh, you know what? I'm honestly, let's go back to mode. And let's live, I mean, I know everyone likes math prints. I call it math print, but you know enough about mathematics now. You're in Algebra 2. Instead of math print, go over to Classic. Select Classic. Just press mode, go over to Classic, press enter, and now take a fraction raised to a fraction, okay? Sometimes these whiz-bang features on the calculator can actually cause more troubles than they attempt to solve. I mean, yeah, sure, now you've got the same thing. Yes, go ahead.
Use the calculator for the test.
Yeah, there's a calculator part and no calculator part. But wait, we're right in the middle. There's something I want to show you. Watch what happens when you go to your y equals menu now. In the y equals menu, arrow down to y2. And let's type in this thing that I created in a flash. I didn't even use a calculator to create this model. I just used 3 building blocks. Start somewhere, multiply by something every so often. Let's just type in this version of it right here. Let's type in 135 times 4 over 135. Here we go. Type in, got to start somewhere, start at 135. Multiply by something, that's 4 divided by 135. Caret, parentheses, x divided by 60. Now what you're about to see is the blue line that came from exponential regression. And then the red line's going to come on top of it. Watch. Get ready. 3, 2, 1. Blue line. Red line's right on top of it.
That's crazy.
Thank you. Thank you. Thank you. Actually, thank you, Dr. Ron Larson, because he's the one who showed me how close those are. So,
Who?
Dr. Ron Larson, I didn't tell fifth grade this. So Ron Larson is the author of the calculus book that we use here at Stevenson High School. And I met him back in the early 90s. The Larson Calculus series is the market leader just on planet Earth. It's not like the whole galaxy, but here on Earth, you
The
know.
whole galaxy. Do you think people
Do you
on
think
Jupiter
it's
use
aliens?
that?
So yeah, I don't even know if he was on Jupiter, but
Do you think they're actually all aliens?
so wait, there's a little bit more. There's more to the story. So then,
You didn't answer the question.
Ron Larson invited me into a writing project for an Algebra 2 book. This is the Algebra 2 written by Larson, Kanold, and Stiff. Kanold was my boss at Stevenson High School, so he hired me and he said, hey, you got to get in on this writing project, because we were writing, because Larson was doing calculus, college math books, but then he said, I want to get into the high school market, so we started doing, so he said, can you write the graphing calculator activity? So I teamed up with Yvonne, you can't see that, okay. So I teamed up with Yvonne Costin to write the graphing calculator activity. So when I was working with Ron Larson, leading textbook publisher, he said, hey, Neil, guess what? Linear functions, and that's my first name. Linear functions and exponential functions, they're really basically the same thing. They both, it's like one is you start somewhere and multiply by something every so often. That was the gist of what he said. I kind of put it into high school friendly terms, but so I came up with and then start somewhere and multiply by something every so often. So to be able to just skip all of the exponential regression and just go straight to the building blocks, that's why we had 3D building blocks first semester for linear functions, so that now we can set it up. So in this unit, they're working on it down in the Idea Lab right now. They're setting up, they're 3D printing we need one more building block to put this on. Here's output change, that's a building block. We need the output ratio. The output ratio building block is coming, it'll be in the Ziploc bags, and we'll all be able to then move the building blocks around on our desks and up here at the screen. So it's coming, thanks to Dr. Larson. Thanks, Ron.
Thanks,
Thanks, Ron.
That's Dr. Larson to you, yes.
Thanks,
So
Dr.
show him this YouTube video so he can see that we linked it.
Yeah, it's all, I wonder. So now, here we go. So having done that,
Wait, I don't think you finished your sentence there. I didn't get the last part.
wait, actually, maybe it's because I didn't fully hear your question. What was your question or your request?
Let's get back to that. Let's get back to that.
All right, okay. So, sorry I missed that. I should have done a better job of listening. So embarrassing. Here we go.
Okay, it
Now, let's jump into, you have in front of you, hopefully this is the case, you have the student notes. So, oh yeah, you don't have the student notes, you have the homework packet. So now I need to teach you how to do the homework packet. Please turn to page 2 of the student notes.
Is this due Monday?
Well, interestingly, the worksheet that you have in front of you, you've already completed the first page of that worksheet, is due tomorrow. The homework,
There's so many.
but you know what? That's why we've got the next 40 minutes for me to show you how quick these go, okay?
Wait,
So,
will we have time to do homework in class or not?
maybe not, but you will have time to find out how, if you know what you're doing, the homework won't take very long. So, Jay, do you mind? Yeah.
What the?
My question exactly. So, here we go. Okay, so here we go. Let's talk about today. We're going to learn not only shifting left and right. We're going to take these exponential parent graphs. We're going to shift them and reflect them over the x-axis and reflect them over the y-axis. That's the new part in the lesson. Reflect over X, reflect over Y. So here we go, let's roll. Some of these are, well, what you'll see on the homework is when you look at the homework solution sheets, you'll see that the problem that you have to do will be just one equation. But for teaching purposes, we're going to show you how this red equation is a child of the blue equation. So this review is not exponential. This is like those. And the cool thing about the homework is that we're not going to make you go through all the details of over 1 up 1, over 2 up 4. No, just get the general shape. Come on, just get the shape. That's how the homework will go fast. Why do I not? It's nothing personal. I just only the camera went in this direction. You'll find out. So I only gave you 2. All right. So sorry about that. So here we go. So that's one thing that'll help the homework go faster. And that is that you can just do 1, 2, 3, 4, 5, and just basically this thing is going down 5. The parent graph will be in blue, and the child graph will be in red. And that's all it takes. It's like these are just really quick sketches, not lots of detail. You will also notice on the homework solutions that I will put a yellow, I'll make the golf ball yellow, the one that actually went down 5. So, for example, this is review of quadratics. Let's get into the new stuff. And whistling makes it hard for me to concentrate. So let's go. So what I'll do is they'll give you a homework question like this. They won't give you the equation of the parent graph. We're just doing that in the classroom. What you're going to have to do is look at this and say, oh, that's exponential. What is it, growth or decay, class? Is it growth or decay? It's growth. It's growth. A is 1, so this population starts at 1 million people. It doubles and so like you don't even have to make sure that it goes through the point 1, 2. Just give it the basic growth shape so that you don't spend all day on the homework. Otherwise, it'll take you too long to figure it out. And then technically, that's a vertical stretch by a factor of 3. But based on the homework that you did for today, you don't even, when you're trying to do this red graph, you would just go straight to it because you'd say we start at 3 million people and then it like doubles every year. So the thing I'd be looking for is, do you have a y-intercept of 3? Are you starting at 3 and does it have the grow shape? As long as you have those 2 things, you're done. The final answer will always be in red. So number 5, it's just review. Just review, nothing new. Try number 5 on your own. And when you're done, look up here to see if we've got it. 1, and that's it, you're all done. This population starts at 1, and it has a 50% drop every year. So basically, it has exponential decay. And let's not even look at the parent graph here at number 6. Let's just sketch this thing, this population that starts at 4 and has exponential decay. 1, 2, 3, 4. When you're done with number 6, take a peek up here. See how fast these go? Now, hopefully, you have hope that these homework problems won't take all day.
I hope.
Okay, good. So here we go. Now, in this one, I am going to, you'll see on the homework solutions, if I use a parent graph, I will write it in blue. So the parent graph is 2 to the x. So we start at 1 and we're going up. That's all you need there. And then I'm going to ask that you show me what's going on in your mind in terms of shifting. Would you agree that we're going to take the blue parent graph and go up 3?
Sure.
Is that how you're interpreting that equation? Well, then would you please just write up 3 and then take the blue curve and move it up 1, 2, 3, so now we're up to 4. But can someone explain to me why this graph is not a full credit graph? It doesn't have the asymptote. So put the asymptote. Remember, asymptotes of child graphs are sensitive to up-down shifts, which reminds me, I skipped the asymptotes on all the other ones. Better go back and put them in, since everyone is watching. Okay, so y equals 0 is the equation of, let me, Kleenex. Someone took all my Kleenex. So, oh, there it is. Oh, yes. Any questions on number 7? Yes.
How do you know where to put the
The asymptote is always indicated by the up-down shift. So, if we're going down 4, the asymptote's at y equals -4. You ignore left-right shifts. Asymptotes of parent graphs are sensitive only to vertical shifting, not reflecting. Yeah, question.
Why is the red graph up 4?
It's up 3. Because look, we did start at 1, right? This population, the parent graph started at 1 million people and then doubled. So start at 1. Shifting up 3 takes us from 1 up 3 to 4. It's just because 1 plus 3 equals 4. That's all we're doing there. That's all we're doing. So try numbers 8 and 9 on your own. Try 8 and 9 for practice. Enjoy the speed. Okay. When you're done with number 8, you can look, see if we agree. Okay, my work's a little messy here, but basically what happened was I got a horizontal asymptote at y equals -4. It went down 4 from 1 is -3. So the point going through the axis, which on the homework solutions, it'll be, bring your attention to it by putting that in yellow there. And should have been red. There it is. Any questions on problem 8? Problem 8, we're good? Raise your hand if you got problem 8 to match mine on your own. It's like, yeah, that's what you did. You're good to go. See, this is happening. And then this one, final answer on this one was down 5. So the horizontal asymptote should be labeled y equals -5. And the original parent graph, by the way, was 2 times 4 to the x. So if you take 2 times 4 to the x, the population starts at 2, experiencing growth. And if you shift that thing down 5, then take a look at this starting point of 2 minus 5 is -3. So that means that the final answer in red starts at -3 and undergoes growth. Let's just pause here. Any questions on problem 9? Yes?
Wait, for 8, how is it y equals 4?
That's a y equals -4.
Okay.
It's y equals -4 for the equation of the horizontal asymptote. Are there any other questions on this page before we move on? Yes, Gerald.
Okay, so you put like parent graphs for number 7 and number 9, like, is that like an every time thing? Like, why do you use the parent graphs?
Yeah, you know what? Look at how useful this parent graph, short answer to your question, yes, use the parent graph every time. So the parent graph was just this piece of it, started to exponential growth. See, now we have a starting point that when we shift down 5, and that is one thing I left out here. I want you to write DN5 here to show me that you understand the interpretation. So you just take this point from the parent graph and go down 5 to -3. Okay, further questions on
Do
that?
that on the homework.
Yeah, do that on the homework too. Show the parent graph and the child graph. And some of these, it gets a little more complicated, so you might want to show some intermediate steps. Last call for questions on this page.
What
Yeah.
do you mean parent graph and child graph?
Oh yeah, the parent graph, I mean, we have, so far in this course, we have used a small number of parent graphs. The x-squared parent graph looks like this. It can be shifted left, right, up, and down to get an infinite number of children. Like, for example, y equals x minus 2 squared is a child of the x-squared parent. It's found by shifting the x-squared parent 2 units to the right. So in this case, red is the parent, blue is a child. Now, we've also got, and this is standard mathematical language that even our textbook uses, so it's important to get up on this vocabulary. The textbook doesn't use the child terminology, but it's essentially what's going on. There's a lot of math educators who do use parent coupled with child, but sometimes with changing definitions of the family and society. Not the Bible, of course. The Bible's the same definition, but in society, they sometimes get a little bit nervous about using family terminology, and so they just kind of stay away from it. But that's actually a really helpful thing. It's like, this blue graph is a child of that parent. So we have another parent absolute value of x, which looks like this.
So you want us to do that on our homework?
Want you to put the parent and the child on your
Even
homework.
though it doesn't ask for the parent?
Even though it doesn't specifically ask for it, we want you to show both the parent and the child. So the third parent we've looked at in this course is square root of x, which looks like this. That can be shifted up, down, left, and right. The fourth parent we've looked at is the cube root of x, which looks like this. And now we have a whole class of parents that is y equals like 2 to the x, y equals 3 to the x. That's a parent. These are parent graphs that can be shifted up, down, left, and right. They're exponential growth curves. I mean, there's an infinite number of parents over here, but they all have the same basic idea, and that is that you start somewhere and multiply by something every so often. If you had 4 times 1/2 to the x, we're going to be thinking of that as a parent graph. And that can be shifted up, down, left, and right. It's the parent graph that starts at 4 and undergoes exponential decay. So by parent graphs, we mean the big 4 here, and then any exponential function that starts somewhere and multiplies by something every so often. That also qualifies as a parent. So now let's do a few examples with these. Let's go to problem 10. Would you please write down the parent graph for this one, which is y equals 6 to the x. Would you now take a moment, sketch the graph of the y equals 6 to the x parent function, and then we'll go through a procedure to obtain the child of that parent. When you're done, look up here and see if we agree on the parent graph. Notice, to save time, we're not expecting you to draw the asymptote of the parent graph.
Sure.
Okay? So the only asymptote you have to draw is for the child graph. Okay, now there are 2 shifts occurring here. One is, as indicated by the -2, what is that shift? Is it 2 up, down, left, or right, class? Up, down, left, or right? I'm listening.
It's right. Or, no.
I'm hearing some rights, some lefts. It is an inverse operation, so when it says -2, remember your mind is going to think left 2, but it's actually right 2. It's an inverse operation, kind of like watching the movie backwards. So right 2, but we also have to go, does this indicate up 4 or down 4? It does indicate up 4, and if you want to have consistency and you're watching the movie backwards metaphor, just take the numbers that affect y, put them next to y. Take the numbers that affect x, put them next to x, and you see that once you put the 4 on the other side, -4 is also inverse. It's not down 4, it's up 4. So right 2, up 4. Please write these 2 phrases, because that's going to be, the green step will be the intermediate step, and the red step will be the final step. So the intermediate step is where we shift this graph to the right 2. So take our starting point of 1, go right 2, and draw a little exponential growth curve. Nothing fancy. And then let's go up 4, which that's the final result. We go from blue to green, then from green. Oh, I just remembered something. I don't want to put this intermediate step in green. On the homework solutions, I put the intermediate step in purple, because green is used for the asymptote consistently throughout the solution. So we go from green to purple by shifting right 2, and then up 4 takes us to the final answer, which I always put in red. 1, 2, 3, 4 gives us an exponential growth curve right here. Purple point up, 1, 2, 3, 4. There it is. Final answer has a golf ball located at the point 2, 5. But all we did was we took the first golf ball, which is at 0, 1, we shifted it right 2 and up 4, and we maintained the family resemblance. This is the exponential growth curve. So you can see the family resemblance. All 3 of these curves belong to the same family. Any questions on that one? It's a crucial example of what's going on.
Why is the dotted line not on the 4? Like, why is it?
Up 4. 1, 2, 3, 4. It's pretty. Sometimes I don't put it right on it because sometimes these lines are thick, so I'm in the habit of putting it a little bit below, but it's really, mathematically, it's on the line. My intention is to communicate that this green asymptote is the horizontal line y equals 4. So if you put it right on the line, that's full credit also. Further questions on this?
But if it's right 2 and then up 4, shouldn't it be up 1 more where the yellow dot is?
Well, remember, if I were to put in the original asymptote was on the x-axis. So if you shift this original asymptote from the parent graph up 4, then it'll be at 4, because 0 plus 4 is 4. So that's all that's happening there. Further questions? Yes? Yeah, not during the lecture. We had some problems with, it's like, it actually got to the point where it was like, people were queuing up in line. Everyone was, wanting, it's like, so then I talked with Mr. McDonald. He said, look, not during the lecture. I know this is a long day. If it's an emergency, of course you can go, but it's not, no, we're not going to be like lining up to escape to the bathroom. Now, let's take a look at number 11. On number 11, we have a parent graph of y equals 1/5 to the x. That's the parent graph, okay? So let's draw the parent graph, which starts at 1 and has exponential decay. And can someone give me the shift narrative here? The narrative for number 10 was take the parent graph and go right 2, up 4. So it was right 2, up 4. What is it for this one? Who can give me the 2-step narrative of shifting for this one? Let's go with Alana.
Left 1, down 3.
Yeah, so left 1 I'm going to do in purple. That's correct. Left 1, and then down 3 will be in red. Down 3. Please write these little narratives. I guess they're codes in a way. These narrative codes on your paper, and then see if you can come up with the child graph. Left 1. Down 3. And then make sure the asymptote also goes down 3. When you're done, look up here to see if we agree. The only thing you need is the point -1, -2, a decay curve, and an asymptote labeled y equals -3. These go pretty smoothly, don't they? Gerald, go ahead.
I probably missed it, but how do you know if it's a decay curve or a growth?
If the base of the exponential expression, the b value is what it is. If b is between 0 and 1, then the graph undergoes decay. If this b value, here a was equal to 1 and b is 1/5, do you agree with those designations? So if b is between 0 and 1, we have decay. If b is greater than 1, then we're going to see growth. All right? So let's try number 12. Try number 12 on your own. Take it from start to finish. Let's see what you come up with. Write the little 2-step narrative and then take it from there. Parent to child. Hope you're using a parent graph 2 to the x. Here's the intermediate, the purple step. If you've made it to the purple step, you can look up here to see if we agree. All right. So hopefully your horizontal asymptote is labeled y equals -5. And when you drop this point down 5, you go 1, 2, 3, 4, 5. It's right there. So you got an exponential growth curve that goes to the point -1, 2, 3. It's at -3, coming -4. Out of curiosity, how many of you came up with the same red graph and we're good to go? Questions? Bethany, go.
Do you want us to do all 3 steps, or can you, on the homework, or can we just skip this?
Look, if you can go straight from parent to child, I mean, I'm fine with that. This is primarily for teaching purposes. As long as you can get this final answer, you're good. Okay? Further questions? Yeah, so, but please do specify the parent, because if there's a mistake, I might see, oh, well, they had the incorrect parent graph, that's why. Now we're going to do something new. Instead of just up, down, left, right, we're going to do reflections. coded REF. So here we go. And there's a parent graph of 2 to the x here. So please sketch the parent graph 2 to the x. And let's talk about what effect would putting a negative sign out front be. Now, I would like to show you that, first of all, the negative sign is not up here in the exponent. So the negative sign is not having an effect in the x direction. Watch what happens when you divide this equation by -1, you get y over -1 equals 2 to the x. Now, think of the inverse operations kind of like a movie where there's dividing the y's by -1. The inverse of divide by -1 is multiply by -1. If you were to take a parent graph and multiply the y coordinates of every point by -1, that would flip it over the x-axis. Like 2 times -1 is -2. Up here, 4 times -1 is -4. Every golf ball would change from having a positive height to a negative height. So the graph would, watch my arms, it would flip. Now flip is not an official mathematical word, but reflect is. So it would flip or reflect from above the x-axis to below the x-axis. That's the effect of that -1. So we document that with REF. When you see a negative out front, that's going to reflect the parent graph over the x-axis. And so the only thing you have to do to get full credit on a graph like this, by the way, reflections have no effect on the asymptote. The asymptote is still y equals 0. So all you gotta do is go from +1 to -1, and just, it's flipped. Vertical flip. Again, a flip is not an official mathematical word, but a reflection is. And so it just reflects over the x-axis. It's like it's looking in the mirror. Any questions on how to get this red graph for number 13? All right. Same thing in number 14. If you have an exponential decay parent, it looks like this. When you flip it over the x-axis, it looks like that. It just reflected. So in addition to the asymptote, it's like that's all there is to it. You're done. You're done. So this one has both a reflection over x, and I can't believe I forgot to document this, reflection over x. So this one has reflection over the x-axis, and then we're going to go down 3. So for down, I don't want to burden you with all sorts of documentation, just dn. dn is fine for down. And understand that now reflect x is the purple step, reflect x is the intermediate. So let's get the parent up here. The parent is an exponential growth curve. It's growth. The purple intermediate step comes from reflecting over the x-axis, so reflect x. Now take the purple graph, down 3, we'll put an asymptote at y equals -3. And we're just going to take this purple graph, shift it down, 1, 2, 3. Final answer in red passes through the point 0, -4, because -1 minus 3 is -4. And it just looks like this. It's the purple graph shifted. So it's kind of like purple is parent of red, which makes blue the grandparent of red. So grandparent, parent, regular person. Okay? Any questions on this one? Any questions? I'm not blocking the view. Were you able to see that over here? You able to see what's going on? All right. All right, so now for the last new concept of the day, and that is a reflection over the y-axis. We've done reflections over x. Now we're going to do reflections over the y-axis. Okay? So an exponential growth curve that reflects over the y-axis will look kind of like this. Wait for it. Okay? I'm sorry. Okay, so here we go. Reflecting over the x-axis. Now, the y-axis. This is an exponential decay curve. So this parent graph, here it is. 1 million people at the beginning, and then 9/50ths of them show up every year, which means 41/50ths of them have disappeared. 9/50ths of them show up, and 41/50ths of them get away every year. So that's the parent graph. This negative in front of the x, it takes the opposite of all the x coordinates, which reflects it over. So in red, the final answer on problem 16, documented with ref for reflect y, reflect over the y-axis, gives you this thing, where thing represents graph. Horizontal asymptote y equals 0. Any questions on how to reflect the blue graph over the y-axis? No? No question? Oh, try this one. Try number 17 on your own. 17, it's all yours. Ooh. Teal. Are you kidding me? Oh. Reflect. So when you're done, look up here, see if you came up with this red graph and its accompanying horizontal asymptote. Any questions? Questions on this one? I got a lot of questions. Okay, no, none? All right. What's going on here? 18 doesn't exist. Oh, let's go to the last page. Is this putting it all together? We're on the last page. And by the way, I don't know what's going on here, but yeah, we got a lot of time. We have I'm happy about this. How about, let's go to some of the tough ones. Putting it all together. Come on, don't make us do stuff we've already done. Let's go down to the super hard ones. The super hard ones are, just so you know, 24. It could be harder. Yeah, actually, 26, 24, 26, and 27 are worth our time. And then maybe I can, if we do these three, then you'll be prepared for the hard stuff. And I might even be able to turn you loose and you can start whipping these things out on the homework. So here we go. Let's get these three and then I'll turn you loose. This has a lot of steps. And what order do you do them in? Anything that has to do with, sorry, that one's not hard enough. This one's hard enough. 26 is challenging enough to be worth our time. The parent graph on this thing is y equals 2 times 3 to the x. So please sketch 2 times 3 to the x as a parent graph. And then there's going to be an intermediate to get to the child. When you're done with the parent graph, look up here, see if we agree. Starts at 2, growth. Start at 2, growth, that's all you need. It doesn't matter whether you do reflect, this minus sign here is reflect x, that minus sign there is reflect. It doesn't matter what order you do them in. Just pick one and go. In terms of reflections, there's no specified order. No order of operations. Just do one then the other. So which one do you want to do first? You want to reflect x or reflect y? Class?
X.
Okay, and that's in reference to this guy right here. We're going to reflect x, and then we're going to reflect y. See if you can do it. See if you can reflect first over the x in purple, and then over the y to get the final red one. All right, that's my reflect x. Now take purple and reflect it over y to get this red graph. So that was 2 reflections. That was a little bit harder than what we've done before. Now, if you had done reflect y first and then reflect x, you would have ended up with the same red graph. It just doesn't matter in which order you perform the reflections. I did reflect x, reflect y. In your mathematical imagination, you might be able to see that doing reflect y, reflect x get you the same answer. Any questions on this one? Yes, Thomas.
Why is it up to? How do you know?
Oh, you know what? The fact that you asked that question caused me to remember that I neglected to put in the asymptote at y equals 0. So let's take this one step at a time. First of all, let's go blue to purple. I was attempting to perform a reflection over the x-axis. Do you agree, Thomas, that when I reflect the blue parent graph to this purple intermediate child graph, that I get this purple graph? Positive 2 becomes negative 2. Okay, so now I just reflect the purple graph over the y-axis to get this red graph.
But how'd you get 2 for the blue?
Well, remember the parent graph started at 2. So
3 is the 3 just worthless?
it's not worthless. If we bumped up the standards, we would do this. Kind of like on the homework that was due today. We just, we eased up on the standards because we didn't want you taking all day with this. But if we did want you to take all day with it, we would say, okay, start at 2, and then it triples. Well, what is 2 times 3 is 6, so
Okay.
2, 3, 4, 5, 6. So then we would have said, hey, you can't just go drawing any exponential growth curve. You've got to be careful to go through this point that has tripled the population of 2. 2 tripled is 6. But since we've lowered the standards on our expectations, we just want you to get the general shape of what's going on. We're saying, hey, this is good enough. So with higher standards, the 3 would make a difference. Thanks for asking that. Further questions? All right, now the last one. The last one is super hard because there's 3 things happening. So that means we're going to have 2 intermediate steps, which happens only a couple of times on homework, but I want you to be ready for it. So here we go. The hardest one of the lesson. We've got a parent graph of 2 times 3 to the x. So let's just get the parent on here first. This is going to be our starting point. And look, just for fun, Thomas, I'm going to put it, I'm going to actually have it triple from 2 to 6. Okay, didn't have to do that. Just start at 2 and growth, and you're good. Okay, here we go. Let's document what's going to happen. In the y direction, we've got a reflection over x and an up 4. In the x direction, we just have a reflection over the y-axis. I like to handle the x's first when there's a bottleneck of things that we have to deal with. So look, that minus here, that tells us we're going to reflect over the y-axis. Okay, I'll do that first. Now for the y direction, there's 2 things, a reflection and a shift. Do the reflection first. Here, order of operations does matter. I'm going to shift over to orange. I don't know. Let's shift over to, we're in purple. Just go to teal. So teal will be where I reflect over the x-axis. And then the up 4 will be my final step. So there's going to be 2 intermediate steps. So total 4 graphs. Parent, intermediate 1, intermediate 2, and then child. Parent, intermediate 1, so there'll be a total of 4 graphs. Only one of them will have an asymptote. Okay, so let's do them one at a time. Let's reflect over the y-axis, which kind of looks like this. Now reflect that purple graph over the x-axis in teal. It's at -2. And now take the teal graph and shift that thing up 4. So the only asymptote you need is on the final answer at y equals 4. And do me a favor and just take this teal graph, which contains a golf ball at 0, -2, golf ball 0 is at -2. Just shift that -2 golf ball up 4. 1, 2, 3, 4. There it is. Has the same shape. It's approaching the asymptote. That's all there is to it. Blue to purple, purple to teal, and teal up to red. There it is. You got 7 minutes to work on the homework. You might be able to get a lot of this done. Go for it. It's a paper submission due tomorrow. Thanks for joining us today. Like us on Facebook. Have a good night.